Okay, guys, come on in, get a seat, we'll get started. Thank you all for coming today. My name is Conor Cunningham. I'm a principal software architect at Microsoft. I work on the core engine. You know me most as the query processor guy. I'm going to be doing a talk today on distributed query, which is a feature inside of SQL Server. Everyone in the back can still hear okay? Yes, sounds good. Excellent. So, how many people have been to one of my talks before, either SQL Bits or elsewhere? Okay, fair number of repeat. That's a good sign, right? Well, at least either that or you've brought in vegetables. So we'll see which it is by the end. Thank you all for coming. My talks tend to be a little detailed, but I try to make it so that each topic's approachable. So if you get lost in the middle, raise your hand. Let me know. If you have questions you want to talk about one-on-one at the end, that's fine too. If we run out of time here, I'll go to the SQL Cat clinic room afterwards, and you guys can ask me questions for as long as you want. I don't have any more talks today after this one. I have been at SQL Bits now. This is my third year, and I'm doing 3 talks this year. This is the first of my talks. I do the keynote tomorrow, and then another talk tomorrow afternoon on data warehousing with Thomas Kaiser from the Cat team. One of the reasons I come out and do these talks, I really love talking to customers because you guys have scenarios that help me when I go do my job. Effectively, the types of scenarios that you do give us insight to figure out, well, should we go work on this feature or that feature a little bit more when we prioritize? Or when we're tweaking features, we can understand what scenarios we can use to justify either fixing a bug or maybe deferring a bug. So that feedback is really valuable to me, and I appreciate hearing anything about what you guys would like to tell me. So anyone who wants to chat with me afterwards about what they're doing, if they think it's interesting, by all means, let me know. Okay, so I'm going to try to teach you today a little bit about distributed query. Distributed query is a feature that's been in SQL Server for a while. It's a very useful feature, and it has lots of sort of magic that most people don't really understand. So I thought it would be nice to do a talk to sort of demystify some of the challenging bits of the architecture and how it works so that you can sort of think about it the way that I do. And hopefully that can help you whenever you're trying to deploy your next solution. You can say, oh yes, distributed query might be able to help here. Or if you already have a feature, an implementation of something using distributed query and it's not quite working right for you, maybe you can troubleshoot it a bit more easily after this talk. So those are the goals of my talk today. I want to just give you a nice overview of what works and what doesn't and how you can leverage that to your best benefit. So this is the agenda. We'll be basically going through why distributed query, and I have a 1-slide summary of how the SQL Server Query Optimizer works, which actually is somewhat challenging for me to do because usually I like to get my hands very dirty. So I'll talk about that in brief for the purposes of this talk. Then we'll walk through a few sort of motivating examples and talk about how each of the major components work down the pipeline. And then finally, we'll start talking about a few cases where things are a little funny. Like we have a scale-out feature called Distributed Partitioned Views, and then some of the nasty troubleshooting cases that customers often run into in the field. Okay, so let's start talking about why you would care to use distributed query, because it seems almost like a luxury in some respects, except people in SQL Server have become so used to it that if you tell them they can't have it, then, well, it actually gets them flummoxed at first. How many people here have tried using SQL Azure? No, not a couple of you, okay. How many people know that in SQL Azure, there's no distributed query yet? Right? How many people, so as a guy who worked on distributed query, I was actually pretty pissed off about this. I'm like, what? No distributed query? Blah, blah, blah. And I beat my chest for a while. And the other engineers were like, yes, yes, Conor, get back to work. And we'll get to that. And so ultimately, it was really interesting to see. But I sort of went back to first principles on why do we have distributed query and what sorts of things are there. And I thought it'd be nice to give a talk because it's actually an area where, in this area, since right this second it doesn't work in SQL Azure, customers who have applications might not really rationalize or fully understand why they use it or that they are using it. And walking through the scenarios might help them think about that a bit more crisply. And it might also help me fish for people who might want to use it on SQL Azure. So let's say that I have 2 different departments in my company. One does billing, one does sales, and I want to be able to generate a report across those 2. I can't move the data from one to the other because it's too big, or some DBA over here owns one set of the data, another DBA owns another set of the data, and my job is just to report on it. This is a very common scenario, especially in medium-sized businesses, where different departments have their own stovepipes of data, and they want to be able to work with each other, but they don't want to give up control of their data. That's sort of common case number 1, and hopefully both of those are running on SQL Server, and you can kind of just talk back and forth. How many people have actually ever used a 4-part name, open query, or one of those open data sources? I assume that some of you self-selected before you came to this talk. that this would be the reason to be there. So this is using distributed query, the feature, and it can go talk from one server to the other to pull data back. And the optimizer is very smart to try to make that as fast as possible. So other scenarios that you have are, I don't own the data server at all, but I just like to report on it. So you just want to talk to someone, get permission to look at their data. I often do this inside of Microsoft when I'm asked to go help people. So I want to go look at a large data set, explore it a little bit, figure out what to do, maybe generate some initial thoughts on a new feature we should build based on how their system works. And this lets me go explore that even though I don't want to get a whole copy of their database, because sometimes they can be terabytes in size and I don't have that much disk space. Another scenario I see very commonly is databases are managed by one guy or girl, and they have 100 servers. They're all SharePoint servers, for example, and they want to back them all up, and they want to have administrative scripts they can run from one server that goes and talks to lots of different servers. So this is another area where we see people trying to automate their workflow and be able to basically make administration easier. And then we have another set of people who just don't want to use SSIS. Either they don't have the expertise in it, or they just think it's overkill, or they just want to copy a table from one place to another. Distributed query is sort of a simple, cheap version of SSIS, and you can run it if you're just a back-end person and you want to go get your data without thinking about having a package and deploying it and blah, blah, blah. This works for that as well. So the way I like to describe distributed query internally is it's like duct tape. Do you call it duct tape in England? Yeah, duct tape? I never know when I'm going to walk over a cultural barrier, so we'll see. I learned about obscene names for people from the north of England this trip, and I won't repeat them here, but I'll just tell you that I've been an education for me, and I almost walked into all sorts of trouble because I almost compared the north of England to Scotland, and it's purely honest, right? I'm from Texas. I don't know any better, but at the same time, I don't want to offend anyone, so we'll see. Anyway, distributed query is a great thing. It's like Spackle. You can fill in a lot of holes, and if you don't have enough money in your budget to go solve some problem with a big solution, distributed query often just patches it up and makes things go away. And that's actually the reason I kind of like it. It's very, very useful, and it's very hands-on. Okay, so now in order for me to give you a great talk about what the distributed query feature does, I have to sort of walk you through what an optimizer does. I've done a talk here at SQL Bits 2 years ago on basically an overview of the query optimizer in SQL Server. I'm not going to be able to go through that talk again here, obviously, but I'll give you sort of a quick summary for the sake of this discussion of what pieces you need to know. I'll encourage you, if you need to see the talk, it's still up on SQLBits.com. You can go watch that, and my slide decks are available on my blog, which is Conor versus SQL. If you just bing for that, you can find it. So inside the optimizer, the job of the optimizer is to take some sort of logical tree representing a query and then convert that into a final query plan. And the operations that are key in this is that the optimizer is actually searching a big space of possible plans and trying to figure out what is the plan that's most efficient for you. It has a cardinality model where it tries to guess the number of rows that are going to come back from each operation, and it has a costing model. And it also keeps track of lots of different parts of subtrees at the same time in memory while it's compiling, and when it gets to the end, it picks the one that it thinks the best, throws the rest out, and gives you back the plan. And you guys view this black box as compilation. And when it works great, you're extremely happy. And when it doesn't work so great, I hear about it from all of you. Statistically, therefore, I get to talk to many of you because even if we do a 99% great job, you're going to compile more than 100 queries in your lifetime, so odds are I'll get to talk to at least each of you more than once. So for this discussion, operators are formed into trees, and they represent operations that need to happen. They represent a bottom-up form of the tree. When you see it in SSMS, it's left to right. We have properties on trees. So for example, is something a key on a column? We'll keep that for every individual operator, and we'll say, oh yes, it's a key here, but not a key here. And various transformations that we do in the optimizer are based on our understanding of that subtree or that subquery and how much it might return or what kind of things, is it sorted, things like that. So we keep track of all this stuff. The optimizer has this relational algebra, and we spend all day pondering the universe about how to make that run faster. But fundamentally, there's these transformations that are happening along those lines. We have rules, which are the way we can say the stuff you did in math class when you were in school. If A join B is equivalent to B join A, we have a rule for that. If you have A join B join C and you want to convert that to A join C join B, we have a rule for that. Everything is pretty much like the mathematical equivalences you learned in school, except it works on a set theory instead of on scalars. So we have a memo structure, and this keeps track of all the different things we've searched so far so we don't accidentally have a cycle in our exploration. We want to make sure we only explore each area once, and the memo structure helps us keep track of what we've seen before so that we don't accidentally have a path which gets back to the same space and repeat the work. And we'll use this in the talk as well. And finally, we have a bunch of magic special sauce, which is, I guess, the commercially good stuff that we use to make sure that we compile plans quickly for you and hopefully get pretty close to the plan that you want most of the time. So now that you're all experts about query optimization, let's move on to the rest of the talk. Okay, so this is the interactive portion. You guys will have to be paying attention during my talk. We'll see. So what is distributed query trying to do when it gets down to it, right? Obviously, we want to run a query and make it work against remote data, but you want it to run quickly, right? Okay, so let's take an example. I don't know if you guys can see in the back, but I installed ZoomIt. I feel very much like a good program manager. Here we are. So I have a query, select sum on call 1, comma call 2 from some remote table, which will be a 4-part name most of the time, but for this case, we'll just keep it logical, where column 3 is greater than 10,000, group by column 2. So in this case, we have scanning a table, a filter on the table, a project on the table, and a group by. Bunch of different operators. What do you want to happen? There's a couple of different answers. You can say, well, I want it to happen as if I had been logged into the other machine. Right? That's sort of a good basic answer, and it works for a while. Or I want it to execute as quickly as possible. That's another possible answer. Right? Philosophically, this is actually a pretty important point. What are we trying to do? We want to make it work quickly, but we don't want to be stupid. And as soon as you start doing complicated things, like joining data from multiple different sources together, then this answer is no longer as if I want to log into that remote machine and type it out, because it wouldn't work from there either. So you have to figure out, what is the distributed query optimization problem? What is the goal it is trying to solve? And in our case, we want to make sure that we give you minimum latency, when possible, for a query against as many sources as you type in. But in practice, most customer use cases, like the 80 or 90% cases, they're querying against one remote source, and they might be joining with local data, or they might just be querying only the remote source. And that goes back to the use cases we talked before. So I claim in this case that what you want is this to happen on the remote side. Select sum call 2 from local table where column 3 greater than 10,000, group by call 2, as if you had typed it in locally, because everything could be done exactly there, and if you did so, it'd be great. Any agree, disagree? There's a quiz at the end. Okay, so since you all got this one already, we'll work our way back to harder examples. Okay. What if I do select star from remote table as T1, remote table as T2? Should I remote this? This is not a question of what the optimizer does. This is a question of what should happen. Anyone? You don't know? You should or should not? Should not. Why not? Right, because there's no join condition, and as a result, you're actually going to return more rows over the network if you remote the whole thing than if you didn't.
Would it depend on cardinality?
Would it depend on cardinality? Yes. So there's cases where maybe we could do some good by remoting the whole thing. Actually, there are exactly cases like this that come up in practice. So if I have 2 one-row tables, it actually is better to remote it. But in general, it's better not to remote it, because essentially I can get n from one side and n from another side and join them together locally, or I can get n squared back. And pulling rows over the network is far more expensive than anything else you're going to do here. So the answer is, don't remote it. Let's take a look. And if you look down here, you can see the first remote query is up on the top, the second remote query is on the bottom, and then there's a nested loop join to put them together. And if you look closely, you can see there's also this table spool. Why?
Otherwise, the query will be executed over and over again.
Right. So if you want to get 2 n rows, you have the spool, because you want to cache the remote side once, because every row of the top will mean that we'll run the inner side tree. And so as a result, you want to not run that remote query, because every time, and then if you just did the default plan with no spool, you would actually still pull n squared rows over, and you would actually do it with n plus 1 queries. And that's not good. That's when you guys start hurling vegetables at me. So the spool means I'm going to take a bunch of space locally, cache that if possible, spill it to disk if necessary, and that way I actually run the remote query up there once and the remote query down there once, and that's it. Okay, very good. Okay. I have a small local table, and I have a large remote table. So let's say the small local table is my bugs. I'm a developer. The big table is all the bugs for the whole company. For SQL Server, we have a bug database that has several 100,000 bugs historically in it that we fix before we release software. So you could, if you were to run this with the naive algorithm, you would say, oh yeah, I can't remote the join because it's joining a local table with the remote table. That doesn't make any sense. I have to pull the whole remote table over and then join it locally. But we just talked about how that's pretty slow. So what to do? Anyone? Not an MVP, come on. Pardon me? Execute remotely and push the smaller table. So if you could go change your application, you could go to the remote thing and run the query from there. And that problem would be not as bad because you'd pull just the local table over, right? Great. Let's say that I don't own the remote machine and I can't run things over there, just to make it a little harder. But you're right, it's perfectly reasonable if you own both machines. Push the local table to the remote side. Yes, so you could actually figure out how to encode that. You have table constructors in SQL Server. That's a very good idea. It's not currently what we do, but it's perfectly valid. Yes, sir. Right, so you could do less than pushing the whole table across. You could push just the join keys across. This is called semi-join pushing. And that's actually what we do. And we do this currently in SQL Server one row at a time for this release that's out. Let's take a look there. Okay, so we have a table scan, which is the local table, and we're joining. And on the inner side, we do this, of course, once per row from the outer side. So you hope this works for a small local table. And then down here, we have a query. And if you look at the query, select the computer. We have this thing called the decoder, which takes trees and puts them back into SQL, and it looks like it was written by a machine. And the only real redeeming quality about it is it's easier to read than XML. So you can take a look and see, oh, okay, it's all the same stuff, but it doesn't look exactly the way you wrote it before. And the main property that's important here is where column 1 equals question mark. So we make a parameterized query for the remote query and say, oh yes, let's take the column, the join key, and actually pass that across as a parameter, and this is the query we're going to execute. So we're only going to pull back the rows that qualify the join. So therefore, I don't have to pull the whole remote table across, which can make it work a lot faster without having to figure out how to change the domain where I might be executing the query. So that works pretty well if I have a small number of rows on the local side. And my remote side supports parameterized queries, which of course SQL Server does, and most of the big other relational vendors do. Sometimes I can have OLID providers that don't support parameterized queries, but it's not that common for things that people use today. So I hope I'm giving you a sense that the problem is not quite as simple as just remote it. But it is often something where you try to figure out the smartest thing you can remote. So when you look at the local optimization problem, compare it to the remote one, you have several things that are different. First of all, having the data be remote means you have to think differently about how you optimize. That network cost is actually very, very high. Back in the days when distributed query was first written, networks were 10 megabits, so it was extremely expensive to pull data over the network. These days, of course, you have 10 or greater gigabits per second Ethernet, and it's possible that it's not actually that slow to go across the network at all, but typically you still don't want to have to deal with moving lots and lots of data across the network if you don't have to, because even if it's not expensive for one operation, as soon as you start trying to scale your system, the network can become a bottleneck if you've got thousands of people trying to do the same query at the same time, and you're pulling all that data across the network. Additionally, even after you pull it across the network, you still have to do the processing on it. And it's the rough equivalent of doing a table scan versus some sort of seek, if you can get it right. So it's an order of magnitude improvement in performance. So therefore, we just have this heuristic, which is a bit more pragmatic. Remote if we can, and it makes sense. We have several optimizations that we do that are strictly for distributed query, and you'll see a few of them as we walk through here, like this last one where we call it the join to apply case, where we figure out how to turn a regular join into a case that we can parameterize and pass remotely. We also will do some heuristics that we wouldn't do in the local query optimization problem. How many people remember my optimization talk? How many people attended my optimization talk 2 years ago when I got stuck here with the volcano in Iceland? Yes? Okay. How many people remember me talking about local and global group bys? Smaller set? Okay. So you can take a group by and split it into different parts, and you can take part of the group by and operate below a join instead of above a join. And this lets you push down operations that filter rows out, and it kind of acts like a filter. And it's really nice because you can pre-compute part of the aggregates you need for a big aggregate query, and you can do it in parallel on multiple threads. And all of a sudden, you can make your query run a whole lot more quickly, and you guys are very happy because I have to worry about this problem and not you. And ultimately, this kind of optimization heuristically makes sense as soon as you start doing scale-out query processing or distributed query processing. So we have a bunch of heuristics that we turn on just for distributed query, and we do them very aggressively so that whenever you run distributed query, we try to push as much as we can whenever it makes sense. Let's jump one layer deeper. Now is the time when we start talking about how it works, not what should happen logically. So whenever we're talking in the query processor to a remote SQL server, we don't have a special pipe. We're not anything more than a regular client, like SSMS is a client, to that SQL server. So when we connect to it, we're using TDS. We have to have authentication that happens just like everyone else. And this is great because there's nothing special we have to do in terms of protocols. So the protocol that we use to talk TDS currently is OLADB. How many people are experts in OLADB? I have written 5 OLADB providers when I was younger, and it was, well, let's just say I'm doing query processing now because I think it's easier. No, I'm joking. It's actually not that hard, but it is a challenge to go figure out how to write one the first time. And over time, they made it easier. There's templates and stuff. But protocol APIs are basically these things that translate your code into something that goes and talks across the network to get you from point A to point B, get your request and response back, and figure out how to make you happy without thinking too much about that layer. You want it to be as thin as possible. In the case of OLADB, it's a non-managed API to let you talk to data, and it can do a lot of really, really interesting things. SQL NCLI is the name of the provider that we use in SQL Server, and it works pretty well. Most of you use it for some tool, and you just don't realize it. So all I'm saying here is that SQL Server uses the same basic tools as anyone else trying to talk to SQL Server at this point. Now, there are some things that we do that are somewhat special. We care a lot about seeing distributions of columns and statistics and things like that. So we'll go get special commands to go do those requests. No different than what you would do to get those requests. But fundamentally, we spend a lot of time looking very closely at that kind of data so that we can start costing query plans that use distributed query features more successfully and come up with better plans. So the neat part about using OLADB is you don't have to talk just to SQL Server. You can use any OLADB provider and talk pretty much to any backend. We've worked on beating out most of the bugs from remote third-party providers. We actually are one of the best test beds of OLADB providers because we use them very, very stressfully. So we can talk to Oracle and various forms of DB2, either on the mainframe or on Windows. We can talk to Linux. We can talk to Active Directory. There's an OLADB provider for that. We can talk to Exchange Server. We can talk to text files. We can talk to JetBrains, which is Microsoft Access files. You go down the list, there's actually tons and tons of OLADB providers, and there's customers doing lots of different things in each of them. Out of curiosity, how many people have used distributed query to talk to something besides SQL Server? Yeah, okay, a good group, yes. We tend to work a little better with SQL Server than we do with other providers because we spend a bit more time there and our algebra translates more quickly back and forth. But we also want to work well with other providers to the point where you can at least get your basic work running. So the picture that I want you to have as we go through the next set of slides is whenever we talk about, oh yes, here's what would happen in a regular query processor engine, we're just going to override most of those same concepts and figure out how to talk to something that's remote. And we're going to translate that into those standard APIs that you use today from all your rest of your tools. So when Analysis Services talks to SQL Server, they're using the same set of tools. When SSMS talks to SQL Server, it's using the same set of APIs. And that's what SQL Server DQ is. It becomes essentially a client of its own self at that point. So in my talk 2 years ago about query processing, I put up a slide that talked about the general pipeline for how you compile and execute a query. And it was parse, bind, optimize, execute. And that's the steps that you go through to get from the initial SQL text into that final query plan. Now, all of them have their challenges, but optimize is the one that I consider to be the most difficult. But each of them has their own challenges in distributed query because some things don't work the same locally as they do remotely. So let's talk about query binding next. Query binding is the process where we actually look up whether or not the text that you wrote makes any sense. It actually represents real objects in real tables. So is the table name real, and is the column name real? And the way we represent that in SQL Server is we have 4-part names instead of 3-part names. So if you wanted to talk to another server, you would initially say, create link server, and then you would have a name for that server. That becomes your 4-part name. And you say select star from remote dot database name dot schema name dot table name. And we would go parse that out and say, okay, great, we have some name for a link server, some name for a remote database. It's not going to be in the local metadata. We have to go figure out where that is elsewhere. So we take the remote part, figure out, okay, this is the name of the 4-part server. Let's go look up that guy, figure out the connection string, go connect there, and now start figuring out what the tables are over there. So we'll go ask for, does this table exist on your database server? And then the answer is yes. We'll keep going. We'll get the list of columns. We'll get the list of indexes, get all the types, and then we'll start continuing the binding process, just like we had looked at data up from our own metadata. Once we get there, the next thing I need to explain is SQL Server has a set of types, and OLEDB has a set of types. And those are not always exactly one-to-one, right? Not all OLEDB providers will have exactly the same types. For those of you who use SQL Server, we have, how many different date time types do we have now? Like 20 or something, right? It's a lot. So the same problem exists when you start talking to other vendors. Their notion of what a date is actually physically different than our notion of a date. So there's this translation that happens for several of the data types. Others are exactly the same. An int is an int pretty much everywhere. So we have to do some translations, and what we do is say SQL Server's types translate into SQL Server types, and then the rest of it works the same. And at that boundary, we will convert, and sometimes that conversion might be a little lossy. So if you take a floating point number, maybe we have to convert it into a decimal or whatever the number is, however it gets represented in their OLEDB provider, we use that to translate to a particular type mapping on our local side. Finally, we cache all this stuff because, of course, we're going across the network to get all that metadata, and you don't want to do that often. So we'll keep a metadata cache, which will make future compilations more efficient once you set up the first compiler too. Okay, optimization. We've kind of worked through this problem a little conceptually. I'll talk about some of the details now. So we want to remote largest subtrees as our primary mission in life, and it's possible to do that by doing different transformations that put you in a position to say, okay, what is the largest tree that's associated with this source? That's not actually the algorithm that you strictly want to use, but for the purposes of this talk, let's start from that assumption and then see where we have to tweak that. So we use index information, statistics information, and we can also work against providers that support SQL grammars and providers that are just ISAMs. How many people know what an ISAM is? I should explain. Okay. A long, long time ago, before we had databases, there were these things called databases, but they weren't databases like we know today. They were B trees with an API on top of them and no query language, and they were called ISAMs. And you could go and do things like move first and seek, and move next, and lock row and update. It's all very mechanical, and it sucked because every time you wanted to write a query, you had to write a program. You didn't get to use a query processor to go make things work. So there's a lot of providers that actually are out there that work just like storage engines. So they don't expose a query language that makes any sense, and instead they expose indexes. We have the ability to work on this language in our query processor, so we can talk to those kinds of providers as well. And there were several verticals that we worked in for a long time in the manufacturing sector who did nothing but this. So they had an OLEDB provider that they would expose, and when you buy their industrial control, you would get that. So this is an API to let you do extensions if you're an ISV. Okay, so once we get to the point where we're starting to figure out what does it mean to get to the remote source, we have to sort of figure out how do we evaluate different possible plans we could look at. And we have a costing model for remote queries. And generally, we assume remote queries are pretty expensive. So we have, it costs a lot to start this query, and every time we get another row, that's also fairly expensive. So in our costing model, when we're comparing alternatives that could be done locally versus alternatives that we do remotely, the ones that win are the ones that pull the fewest number of rows across that boundary, because that basically will mean your cost function will be very expensive if you pull lots of rows across the wire. And it may be that sometimes it's easier to pull it across in 2 different calls because it's a cross-product case. In other cases, it might be more efficient to say, you know what, I actually just want to run one big remote query. And then we have a bunch of different transformations in the optimizer to sort of find this best case and work our way towards whichever one is the fastest in our model. So I'm going to walk you through an example, a basic example about how the optimizer works. So I think in trees. I'm sure all of you do too, right? No? Come on. I got a smile. Excellent. Okay, so let's talk about this tree. I have a remote source A, a local source B, a remote source C, and I'm joining remote A with B, and then joining the result of that with C. And then I'm doing a group by on columns B and C, and I'm trying to compute an aggregate, which is a sum of a column D that comes from remote C. After a while, I actually prefer viewing queries this way. It's just far easier. But I realize that not all of you are there yet. Anytime you want to come and spend a week with me and doing nothing but this, let me know. We have internships available. So let's do some transformations. Okay, so if we do just pick the remote trees, these triangles represent largest subtrees from that starting point. I've got 2 of them, and it probably isn't that efficient, because I bet you I can actually push some operations remotely and pull fewer rows across that wire. Let's go figure out how to do that. Okay, so I can do a transformation here called joint associativity, where I take C and B and I swap them. If they're inner joins and they're all equijoins, I can do this transformation. And I could have written the query this way originally in syntax if I wanted to. So this is a mathematically equivalent tree to the one that we started with. So now we're exploring in the optimizer, and this is one of the transformations we do. In each step, we'll put another alternative in the tree, and we'll figure out which is the unique subtree that we did. In fact, the rule that runs it doesn't even see the group by. It just looks at join over join and finds out if it does rewrites that make sense. Okay, now you'll notice I've got the 2 remote tables together. So I can make a bigger triangle and remote that larger amount. Starting to get the handle of how this works, yeah? You guys ready? Can we do better? Yes? Okay. Let's do the next step. Okay, now, this is that local global group by case I told you about, where I can add a redundant group by into my query and cut down the number of rows I have to pull around even more. So if you'll see here, I did group by BC, and I ended up changing to group by C. So if I'm just trying to sum rows, well, I can do it in little chunks ahead of time and then just sum the results, and it's the same as if I had summed them all separately, right? Because addition is commutative. So great, now let's push that down below the join, and I can say, hey, you know what? That group by comes from that same remote source. Now I can remote that. So for this particular easy example, this isn't exactly how the optimizer works, but this gives you a rough idea of what's happening, and it gets you pretty close to the answer that would probably be picked for this particular query. This will become interesting later when you ask the question, but why didn't it work for my query? So that's, right? I'm pretty sure that's why most of you are here, actually, but we'll see at the end how many questions I get. Okay, so let's talk about how we execute queries. So far, all I did was a big mathematical model. I came up with a plan, which is great, and that plan looks pretty good now. How do we execute it? Well, just like before, we're not anything special. We're just an OLEDB client. So we would open up an OLEDB connection against that remote server and say, hey, we want to run a query. And we'll do that as part of executing our big query. Some of that might be local. In fact, part of it will always be local. So we open the connection. We'll call IDB properties, set properties, all the things that you would do. Since all of you don't know anything about OLEDB, I'll just tell you the basic steps. You have setting up a text and executing the text, and then you get back a row set, and then you say, I want to get back rows. And you can say get row, get row, get row. For those of you familiar with SQL client, the managed adapter, it's conceptually very similar to that. It's just give me the next row, give me the next row, give me the next row. And when it's done, you close the connection. So one thing we do is we can cache the plan, which is a little different than perhaps you might execute in a regular program. So we'll have the ability to open up a connection or cache it based on how quickly you're running. And we also have this problem that when you execute, we need to check to see, did you change the definition of the tables on the remote side? Because there's nothing stopping you from adding a column or dropping a column from the time we compile to the time we execute. So if that happens and you try to execute, you just get an error saying, hey, this query doesn't bind. This remote query doesn't bind. And customers, I can assure you, they don't like that error. They call us a lot when that happened early in the SQL 7 days. So instead, we actually will go through and look at all the definitions of the columns that come back when we first start executing and see, hey, are they still valid? And if they aren't, then we force a recompilation to happen on the local side to figure out how to generate a new remote query that will execute, if possible, or we'll send an error back to the client. Okay. Finally, one little detail. In the original versions of distributed query, we didn't remote hints to remote server. So if you do select star from remote table with tab lock, for example, I don't know why you'd do this, but maybe someone wants to avoid locks or run a report or run with no lock or whatever. All those things do remote now. So in all recent versions, this is the behavior. So if you're using lock hints, they also work transparently against SQL Server remote providers. If you're trying against Oracle, they'd probably look at you a little funny, so don't do that. Okay, so how do we read a query plan? Okay, this is just joining. This is the earlier case, except I added a top. So select top from A join A. No join predicate. So we open up the remote scan. Well, actually, originally starts off, it says start up the query tree, and then it walks down to each operator. It says start up this operator, start up this operator, start up this operator, down the query tree. Gets to the bottom, and it says start up the remote operation. What do? We open up a connection to the remote source and say, hey, we'd like to run a query against you and get back the results. Okay, great. And after all that's done, then we come back and say get row, get row, get row. Come down to the first left-hand side operator, which, because it's transposed, is the top operator. And it says, okay, give me a row from the remote side. So we could go across the network and get a row, bring it back, send it up to the nested loop join, and then it says, hey, I want to get a row from my other child. Goes over here, calls get row, gets back the data, sends it back, converts it into the local format, and executes just like it's a local operation at that point. Returns back up the row to the top. And then it'll say get the next row. Walk all the way down, getting all of these. Eventually, we'll hit whatever the top limit is, and we'll say, no more rows, and the top will just exit. So we're not going to pull lots more rows from the remote source than we should, which is good, because if all you wanted to see is one row from a remote source, you don't actually want to execute that whole thing and pull it back across the wire. You just want to pull back the rows you need. Now, you actually need this balancing act between pulling back only one row at a time, because that network round trip can be expensive, and pulling over batches of rows. So we actually spend a bunch of time figuring out how do we get groups of them. So we'll send over, I think it's 100 rows at a time. So if you just get one row, we'll probably get 100 rows, maybe, depending on the provider and what the property setups are. So the way you should read this is sort of mechanically like this. Once you have that, we have pulling the rows through, and we're only going to pull all the rows up that we need to. How many people have seen the new batch processing stuff for the column store indexes? So I should point out the model that I'm describing to you is called row processing model, and it's the model that you've been seeing for years and years and years. We have an additional model that we're adding in SQL Server 2012, and I'll be talking about it tomorrow morning. And that's called batch processing. And the way that I'm describing this is not the way that batch processing works. So just be aware that this mechanical one row at a time approach is how you should look at things that say batch mode no or row mode yes, essentially. Okay, very good. Okay, now let's start getting into the advanced topics. How many people have ever heard of the Distributed Transaction Coordinator? Right? And it's your best friend, isn't it? Why on earth is it set up this way? Why is it erroring? Where is it? Who owns this thing? Why do I need it? How come it sometimes succeeds and how come sometimes it fails? I'm sure all of you have at least cursed it once. I have, daily sometimes. Okay, the Distributed Transaction Coordinator is necessary because actually you need a transaction coordinator all the time. It's just you don't see it unless you're using distributed query. How many people know what a distributed transaction coordinator is doing for you? Okay, so let's talk about transactions, right? You have the ability to begin transaction, and you run, and then you commit a transaction locally, and if you're a bank, you don't want to deposit money in someone's account before you take it out of that other person's account, and you want to make sure you absolutely positively take it out of their account before you deposit it in someone else's account, etc. So either you want the whole thing to succeed, or you want the whole thing to fail. And that's what transaction coordinators do. SQL Server has a local transaction coordinator. It's very efficient. It works across databases. So all the databases on one server, they use the local transaction coordinator. Now, let's say that I want to do the same thing, except I have two SQL servers. Well, I have a local transaction coordinator here, and I have a local transaction coordinator here, and I want to have person one's bank account over here and person two's bank account over here. I want to deposit money in this person's account from this person's account. So I begin a transaction, I subtract $10 from that person's account, sorry, 10 pounds, localized talk. And then I go over here and I write it, begin transaction, update my balance, add 10, okay, and then I call commit on both of them. Problem, this one succeeds, this one fails. It ran out of disk space. Machine died. Now you've created $10, pounds. So close. So this is bad. Banks are extremely upset when this happens. This is actually what most online transaction processing is all about. So distributed transaction coordinators, they solve this problem for you. They have a protocol for having local transaction coordinators be able to say either you both commit or you both roll back. Actually, it can work on an arbitrary number. But that's what it does. So the Microsoft Distributed Transaction Coordinator gives you the ability to coordinate different SQL servers so they can actually have transactions commit or abort together. So far, so good? Great. Now, MSDTC is the name of this, and it's a little process that runs, and it's hosted on the domain controller. So the funny part is that if you want to set up a SQL server, now you have to go become friends with the person who's the system administrator. How many people are friends with their system administrator? Yeah, this is actually the problem with distributed transaction coordinators, is you think that it makes great sense to have the person who's the system administrator be the person who sets up that, but ultimately they don't probably care about your application so much, right? That's pretty much my experience, at least. Now, I'm generalizing, of course. There are some great system administrators, and I love them. I love them all. But some of them I love more than others. So this is a problem where getting that set up involves maybe you need to strategically leave some candy on their desk or generally be nice. This is really important. Trust me, you can do so much more once you get the system administrator on their side. And the next slide will have another scenario where this happens. One more thing that's really important about distributed transaction coordinators. So if I want to talk from SQL Server to Oracle, not that, because you're migrating off Oracle, right? And so you say, okay, great. How do I talk? Like, they have a different transaction protocol. So MSDTC does all the hard work of translating from Microsoft's transaction protocol to a bunch of other people's transaction protocols. And this is great. You also can use distributed transaction coordinators even without talking through distributed query. For example, if you have an application tier and you want to coordinate changes to the state of your application with changes to the database, you can actually use distributed transactions across tiers vertically instead of horizontally. And you can say, I only want to make state changes to my business objects if I can commit them as a unit, and figure out how to write your code so that I either commit or roll back that transaction, and the business objects commit or roll back. There's not a ton of people who do this, but it's perfectly valid, and it's actually very valuable in some high-end enterprise applications. Okay, so when you go talk to your system administrator, what you need to say is, hey, I need to make sure that we have permission to talk between these two servers, or from my SQL server to my legacy Oracle server, and I want to be able to have those protocols work. And you have to get them to configure it. And you have to have permission for that protocol to flow back and forth. So make sure you're just really nice to them for that week. Buy them a few candy bars or coffee or whatever it is that floats their boat, and then get that set up, and then everything will start working. But before you do that, I need to tell you about the next slide, because there's one more thing you should talk to your system administrator about, so distributed query will work really nicely. Any questions about distributed transactions before we move on? I realize this is a hard subject. Okay. How many people have ever heard of the double hop problem? Okay, good. How many people understand why they get the double hop problem? Yes, fewer, right? So we have this technology which allows you to have single sign-on. So you log into the domain, and you get this token that lets you pass around credentials to various people. Say, hey, I'd like to log in, and I'm so-and-so. Please give me permission to the SQL Server database. And then you can run queries. And if you are running an IIS server, and you're using that to talk to SQL Server, you've probably hit the double hop problem independent of distributed query. But you can also hit the distributed query problem if you connect to a SQL Server, and you try to connect to another SQL Server in your domain, where you come back with, hey, I can't connect. Why can't I connect? Well, why? What's going on? And this is because you weren't nice to your system administrator again. Or figure out how you can get your system administrator to be nice to you, I guess I should say. So Kerberos is a technology that deals with these tokens, and often the single sign-on that you want to use for getting authentication to work like this in a domain is based on Kerberos. And Kerberos has names for things. And you would name the SQL Server and have a published name. Service principal name is the technical name for it. And you want to be able to say, OK, I want to expose a service principal name. And then I have this need for certain kinds of accounts to allow what's called delegation, which means that I can flow credentials through. By default, Kerberos back in the old days was made by a bunch of academics at MIT, and they thought, client server is the way it works. You probably don't want to do this transitive thing where I can talk to one server and then talk to another server and then talk to another server. But that actually turns out to be the dominant paradigm that Microsoft sells now. So you need to be able to say, I need to allow support for delegation. And this is, again, a little button that the system administrator has to click on their system. And if they don't, then you get this error. And you don't want this error because it's really cool to be able to just flow credentials through. Because if you don't do this, you have to do SQL authentication. And then every single command, you have to figure out who's going to log in, and either you have one account for all of them or you need to have n accounts. And it frankly is just no fun, right? You want to go get that transitive authentication working, delegation in Kerberos. So talk to your system administrator, be nice, see what you can do. Let me know. Send me mail. Tell me what things work. I need to actually create like a little cookbook on best ways to positively influence your domain administrator for the purposes of setting up distributed query. I don't know the best way to do it. To be quite honest with you, they're all a little different and often a little persnickety. So their initial answer is no. So usually on a good day is the best day to approach them and say, you know what I was thinking? I would like to not harass you as much. And the best thing you can do is just give me permission to this so I can just leave you alone. That's the best tack that I've seen work so far, but I'm looking for any techniques that work. There's 2 articles here that you can read that if you can read blue on black. I will post my slides on my blog, but I just search for these. These are basically double hop authentication, setting up Kerberos delegation. If you Bing for those, you can find them as well. So there's nothing special about these. They're not new, but I wanted you to be aware that there are help on what technically you need to do, and I didn't want to go through all the details here today because it's a little technical. Okay, scale out. How many people have ever used distributed partition views? A couple of you. It's not as common these days, but it's still valid for a few scenarios. Distributed partition views was Microsoft's first feature that did scale out. And what it lets you do is say, hey, I want to take a big table that's bigger than one server, and I want to split it up across a bunch of different servers. So maybe if I have a list of all my contacts, and I'm very popular, I have lots and lots of contacts, I'll have A through D, and I'll put them on one server, and then I'll have E through whatever, and I'll put them on the next server, and so on. And then you want to be able to look at it like it's one big table. Later we did table partitioning, and it's essentially the same concept. It's just on one server instead of n servers. So distributed partition views are built on top of distributed query, and they let you be able to build this kind of technology just fine. You can say, hey, I want to select start from a view, and it'll split the query up, run it against a whole bunch of different partitions, all different linked servers, and then you can return back the results. I'm not going to go into all the fun, exciting problems in this space, but I want you to be aware of it and how it works. So we create a view, and it's a union all of select star from this local table, select star from this remote table, and select star from this other remote table on a different remote server, etc. So you can have union all views of up to 255, I believe, partitions. The other thing that's interesting here is each partition has to have a check constraint that describes its portion of the range, so a local check constraint. So the view just sees a big union all query, and it assumes that this pattern means it's a distributed partition view. Each local table will have only that range, and the check constraint blocks you from having things from outside the range. So if you do select star from my contacts view, where name equals Conor, do I need to go touch all the partitions? I can be smart and go, hey, I only need to touch one partition. So there's a whole pile of optimizations about scale out that go into distributed partition views to say, you know what, I really only need to go to the one that has the C's on it and forget all the rest of them. So we can prune those out. So when you go compile queries against this, you can see, oh, I'm only touching one remote server in this case. And that's because we do this kind of optimization using the properties. And at this point, you should go watch the talk I did 2 years ago because it'll give you an idea about the how for the various transformations we do. The other thing that happens is there's some cases where only parameters will tell us which one to go to, like select star from table where column equals parameter. Now, if that's the partitioning key, I know I need to go to exactly one partition, but I don't know which one it is until runtime. So then we go and have all this logic to do runtime startup parameters for each check. We'd say, okay, we only want to look at this guy if the parameter value is in this range, and otherwise go on to the next one. So there's a pile of things we did there. A lot of it is very similar to what you see for partition table optimization, because we basically base partition table optimization on this feature. So in some cases, if you're trying to do scale out yourself, this is a useful tool for some of the administrative acts. I would not suggest doing full scale out using this because it doesn't do parallelism, which is the feature that you would really need to make this work well. Okay, so how many people have run a distributed query and wondered, why doesn't it remote my query? At least a few of you. There's a small Achilles heel in parts of distributed query, which is if some operation you're doing isn't understood by the remote side, or we haven't exposed it properly through our query language so that we can remote it, we can't remote that subtree. So it could be that you call some function that is a UDF, for example. And the UDF makes sense locally, but the UDF doesn't exist on the remote side. And if it did, we don't actually know if it's the same UDF as what you have locally. So we can't just push it. Well, we could, but it would probably surprise some customers, and they'd say, oh, no, I have a very valid reason for having different logic for the same UDF, so we don't remote that. In other cases, we have things like getDate. And what does getDate mean? Give me the local clock on this machine. Well, what if your remote server is not synchronized with the local clock on this machine, or in a different time zone? Well, then I start returning different query results based on whether I remote that getDate call or not. So there's all these complicated cases that customers sort of give me this glazed look when I start explaining to them all the different reasons why you might or might not remote them. And frankly, it kind of sucks because there's things that you'd want to be able to remote that don't make sense. And we don't have every single knob that we need to be able to remote every single query. All the basic stuff works pretty well, but as you start getting into more advanced queries, you can find a case that doesn't work. So I want to tell you how to debug those cases and what to do about them. So if you have a case where you have a query that you think should remote, it's all from the same remote server, 2 or 3 tables, and then something about it isn't remoting, and it may be that it's running slowly, it'd be great to know what to do. So what I typically do first is I read the query and I see, are there any functions, any intrinsic operations in there? If there are, I start saying, okay, can I build an isolated repro where I do select star from whatever the tables were in that subtree to figure out whether or not all of those things remote by themselves, out of context. And eventually I build up a larger and larger tree until I find the first thing that doesn't remote. And if that thing is something that's not necessary for the query, I'll just take it out. And if it ends up being semantically really important that I get right, I can say, you know what, I don't actually want to use this anymore. I need to do something different. And the workaround you typically do is you can use the imperative remoting operator, which we have open query, which you can say, hey, here's the text that I want to really remote. Just run this query and forget trying to do this whole optimization problem. And often if you get to the point where you have a query that works really well, you want to keep it that way, you're the administrator, this is a great way to encode that and say, I don't want anything funny to happen where it ends up running a query for a really long time when it's already finely tuned, so this is a way to force that to happen. So this is your plan forcing for distributed query. Questions? All righty. Oh, I'm done. Okay. Questions from anyone now about anything in the talk? Yes? Yes. Right, so I'll repeat the question. What happens with statistics? Sometimes they don't come back, and I don't understand why, because I'm not the owner of the object and what's up with that, basically. So let me explain. So when you create the link server, you have to pass a credential name, and that credential name is used to go to the remote side and connect to it. When we're connecting to that remote server, we're asking it for a variety of things, including calling the effective equivalent of DBCC show statistics. DBCC show statistics, in the release that's there right now, has a permissions restriction that says the only people who can see statistics on a table are people who are owners of the table or people who are administrators of the remote box. Not all the cases where you want to do distributed query line up exactly with that set of restrictions, right? And it sucks. And it sucked for a long time, and I've tried to fix it for a long time. And I am happy to announce that if you can hold your breath for just a little tiny bit more, I can't tell you when, but let's just say soon, you might find that that set of rules is slightly more expanded to people who have less aggressive permissions. And then it will just start magically working. So hold your breath for soon. Not allowed to tell you when, but you didn't hear it. You know, mum's the word. Hasn't been announced yet, but soon. I have been working on this behind the scenes tirelessly. It sucks because often I hear the same questions for a while, and it's not that I can't, I want to fix it right now. And I go back, and I'm like, we have to fix it right now. And they're like, no, the house is on fire. Go fix this problem. And it's always a question of 10 times more things to do than we have time in the day. And we have to prioritize, and then sometimes I can convince the right set of people, but then I can't get it in the release, and then it gets deferred. Or I get the approval, and then that person leaves, and I have to go get approval again. These are my problems, right? My job is to make your job easier, and I'm just telling you, this one's been on my list for forever. And success is, I don't want to jinx it, so don't tell anyone. Almost there. Almost. I agree. You should be able to see statistics, and then the plan quality will generally improve. It will not do auto statistics. So distributed query doesn't force the creation of auto statistics directly on the remote side. But if you compile a query on the remote side and run it, then it might do auto statistics on the remote side. So that's one nuance, but other than that, you'll be able to generally get statistics there. And if you see cases where you're not getting the exact right plan, you might want to go manually create statistics on the remote side, but that would be the only funny case. You can see that in Profiler. If it calls, give me the statistics object, and there is none, then there you go. But that's the only funny case. Yes, sir?
Profile on the roadside, obviously you see all this LDB chatter going along. Is this essentially what, I mean, I know that the rules are different, but is this essentially what in a local query would be internal is now being exposed to? You can actually
very good advanced question. Okay, so the question was, hey, if I turn on the OLEDB traces in Profiler, there's a whole pile of them, and it's like query interface this, and set command text that, and execute. Is that what's happening locally against the local storage engine when I'm executing a local query? Is that the question? Yeah, it's not exactly the same. It's a different code, but fundamentally, it's in that ballpark, yes. So we do have a storage engine locally. It was originally based on OLEDB. That's how we made the distributed query feature work. Although we have a bunch of things in the local storage engine that don't happen the same way in the remote code path, and a different set of heuristics and rules. So for example, that batching to get 50 rows at a time thing only makes sense when you're talking to something that's expected to be over the network. So we don't do that in the local case. Additionally, the way that locks work is completely different in the local SQL Server case, and it depends a lot on your isolation level. So locks in OLEDB are implicit. The call to get next rows may lock something and then give it back up. And in the internal stuff, we actually have far more granular locking semantics because we're often talking to individual access methods instead of just running a query. But at the meta level, we'll say the 1,000-foot level, yeah, we're doing get rows, and we're calling executes and restarts positions and stuff in that ballpark. I'd say logically yes, physically no. Is that fair? Answer your question? Okay. Yes, sir.
When you've got SQL both sides, why can't you merge together the two plans to show the remote plan and local local?
Right, so the question is, if you have a local SQL server talking to another remote SQL server, can you do something smart and merge the two plans together so that it looks like one big Uber plan? That's a great suggestion. We haven't done that yet. The plan can change at different times on each of them, right? And we are somewhat purposely ignorant of the remote plan. But I would say, if I can step back for a moment and ask the question, why did you make distributed query sort of use OLEDB all the time and be this sort of aloof friend to the remote SQL server, when sometimes you could use advantage of the fact that that's another SQL server, and maybe you could run more quickly, or maybe you could figure out how to give a more integrated experience, or ... right? This is the meta question, if you will. And this is also a great suggestion. I think that over time, we need to basically get to the point where this gets better, but right now in the current versions, we don't do this because it hasn't been the major issue. I think that there's opportunities there if we spend time on this, and you might see things like this in future versions of SQL Server or SQL Azure. I believe that I'm out of time, so what I will do is ask you guys to take any more questions you have, and I'll answer them outside after we get done so you can get to your next meetings. Okay, thank you very much for your attention, and thank you for coming to the talk.